In this video, explanation of the work done in the first two parts and results will be discussed. Two designs are implemented based on design published in the research paper named as Bending and Folding Effect Study of Flexible, Fully Printed and Late-Stage Codified Octagonal Chipless RFID Tags. It comprised tags of dimensions 52 x 82 mm and 52 x 52 mm. First design implemented has dimensions 52 x 52 mm having arrays of 2 x 2 unit cells. Unit cells comprise 7 octagons. Radius is calculated from the dimensions mentioned in the research paper. Substrate is oily paper as used in the research paper. Analyzed for the unbent state, new substrate material PET is introduced, which is then analyzed for bending state of the tag. Tag is bent by drawing cylinder of 60 mm radius for 2 x 3 as well as 2 x 2 arrays of unit cells. 2 x 2 array tag is also analyzed for 16 mm bending both on 2 x 2 array tag is also analyzed for 16 mm bending, and 60 mm bending is done both for paper substrate and PET substrate. Results discussion now. First of all, 2 x 3 array unit cells. Results for unbent 2 x 3 on paper substrate. First of all, tags dimensions are kept as 52 x 82 mm in this designs. Results are simulated and analyzed for the unbent state of the tag, where substrate used for this case is oily paper. Generated RCS response, as you can see, has 5 dips, with first at frequency 4.6236 GHz and the last one at 12.947 Hz. Numerical values or frequencies in gigahertz and their corresponding magnitudes in dBs can be seen. Now, results for bending on 60 mm radius while the substrate is PET. Tags dimensions are kept same, that is 52 x 82 mm. Substrate for this case is PET. PET does not exist in the material library, so no new material is made with the name of PET, having a Pilsen value of 2.9 and loss tangent as 0.0025. A cylinder of radius 60 mm is drawn in order to bend the tag. Octagons and substrates are converted into sheets in order to bend them. Bend operation is applied, after which thickness is assigned to sheets. Result is simulated, and obtained RCS response has 6 dips at the frequency started from 4.1112 GHz to 17.128 GHz. Frequencies with their corresponding magnitudes in dB can be viewed. It can be seen by comparing results for unbent and bent tags that results are slightly shifted backwards in the case of bending. Now, 2 x 2 array unit cells. First of all, unbent state on paper substrate. Second design is implemented by keeping the tags dimensions to be 52 x 52 mm. Array of 2 x 2 unit cells is designed. Dimensions of the unit cells are same as in the first case. Firstly, design is analyzed for the unbent state. Substrate for this case is oily paper. Results obtained for RCS response has starting frequency of 5.0232 GHz and corresponding magnitude is minus 45.963 GHz. Last dip is obtained at frequency 11.286 with the corresponding magnitude of minus 26.985 dB. In total, 5 dips are obtained for the frequency range of 2 GHz to 16 GHz. Further, you can view it from the video. Now, the bending operation. First of all, designs are obtained by the bending on the cylinder of radius 60 mm, but the substrate uses oily paper. Bending operation is same as described before. So design is simulated to obtain RCS response, and total number of dips obtained in this design is 6. Note that substrate is paper here and bending is on radius 60 mm. First dip is obtained at frequency 4.356 GHz having minus 43.279 magnitude in dB. Second dip is obtained at the frequency 5.4122 GHz with minus 35.386 magnitude in dB. Subsequent frequency values and their corresponding magnitudes in dB can be seen. It can be seen that last dip is obtained at 18.404 gigahertz with a magnitude of minus 46.098 dB. In comparison to the results obtained in the case of unbent state to the present scenario, frequencies are shifted towards left. Uh, Results then for bending on radius 60 millimeter, and the substrate here is PET. Substrate of the material is changed to PET and bending is done for the radius of 60 millimeter, and procedure is same as described before. Array is 2 cross 2 and design is simulated for a frequency range of 1 to 20 gigahertz. PET substrate is used and bending is done by using a cylinder of radius 60 millimeter, and array of 2 cross 2 is made on the substrate. Design is simulated through a frequency of 1 gigahertz to 20 gigahertz. RCS response obtained has 7 dips in the simulated frequency range. First dip is achieved at frequency 4.4764 gigahertz with a value of minus 40.417 dB, and the last is at frequency 18.37 gigahertz having magnitude of 38.806 dB. On comparing with the results of unbent states, it can be observed that the dips are shifted towards right. And the last one is the bending on radius of 16 millimeter 2 cross 2 array, and the substrate is PET. Radius of the cylinder on which tag is to be bent is changed to 16 millimeter and then simulated to attain the RCS response. It has total 6 dips starting from a 4.41403 gigahertz frequency to 17.01 gigahertz. Values of frequency and their corresponding magnitudes can be seen. Comparison of the results with the unbent stage shows that frequencies are shifted towards left. Thank you for watching.